Hello, everyone. So today we are going to go ahead and get started with 4.3. We're here, if you have your student journal, we are here on page 107, and we are going to start. So this section, if you want to go ahead and title it, 4.3 has to do with parallel and perpendicular lines. So we've been writing 4.1, okay, we're writing these equations in slope-intercept form. 4.2, okay, it's point-slope form. Now we have to learn how to write these different equations using some information about parallel and perpendicular lines. Okay, so just as a refresher, let's get these vocab terms for both of these types. If you need to, you can always pause the video. All right, but parallel lines are lines that never intersect. Okay, so there are two lines that go at the exact same angle. And obviously, this is not a perfect picture, so that's not exactly, but two lines that are never going to intersect. So they're at the exact same angle. Okay, parallel lines are always going to have the same slope because they have the same angle. If they're never going to intersect, they have to be at the exact same rate of change. Okay, so today we're going to talk about parallel lines. Tomorrow we'll get into perpendicular lines. They're a little bit trickier. But those are lines that intersect at a 90-degree angle. Okay. Again, I'm trying to do this on my computer screen, so it's not going to be perfect. All right, but okay, we've got one here and one here. Okay, they're intersecting there at a 90-degree angle. Okay, so we'll get into perpendicular lines tomorrow. All right, but let's talk about how we can use this information about parallel lines and answer some different questions there. All right, so right here where it talks about parallel lines and slopes. Okay, so two lines in the same plane that never intersect are parallel lines. Okay, well, let's pretend those are straight lines. Okay, two distinct non-vertical lines are parallel if and only if, here, let's find my highlighter again, if and only if they have the same slope. Okay, and then all vertical lines are parallel. So remember, vertical lines are undefined, so they don't have a slope. Okay, so it's saying, okay, all undefined lines, or lines with an undefined slope, I should say, are also parallel to each other. Okay, so let's use that information. We'll get into perpendicular lines. We'll do that tomorrow. It's a little bit more complicated. We've got to use negative reciprocals, but parallel lines are a little bit simpler. It's, do they have the same slope or not? Okay, so let's look at this with a couple different variations. So first off, let's look at this graph right here. Okay, and you can't really just look at the graph and say, oh, they're parallel. If we just kind of glance at this, all of these lines to me kind of look parallel. We have to figure out the actual slope and say, okay, this makes it parallel or this doesn't. Okay, so it's easiest where it gives us the graph like this because we can always do this. Let's look at our rise. Oops, I didn't mean to click on that. We want to look at our rise over run. Okay, so we're going to figure out the slope for A, B, and C, and we'll see which lines, is it all three, is it just two, which lines are actually parallel to each other. Okay, so for A, remember when we're finding these slopes, we always want to go here from left to right. If I was looking at number 2, I'd want to go from this point to this point. Okay, you always want to go from left to right. I think that's the easiest. Okay, because you're thinking, okay, what is my rise? Am I going up or down? Okay, and this one I'm going up 1, 2, 3. So it's going to be a positive 3 right there. And then over 1. Okay, so positive 3, positive 1. I've got a slope of 3 for A. Same thing, I'm going to do this for line B. Okay, so I'm going from here to here, so I'm going up 1, 2, 3, 4. That's my rise. My run, I'm just moving over 1. So I've got a slope right here of 4. So right off the bat, I know that A and B are not parallel. But let's see for line C if that's parallel to anything. Okay, so I'm going from here to here. So I'm going up 1, 2, 3, 4. That's my rise, 4. I'm going over 1. So 4 over 1 is 4. Okay, so I've got 2 lines of the same slope. I've got B and C. So lines B and C are parallel. Okay, some of them, all 3 of them might be parallel. Maybe A and C are parallel. When it's asking you which ones of these lines are parallel, it's asking which of these lines have the same slope. Okay, because parallel lines always have the same slope. All right, now let's take that same concept and let's look at some more problems. Right? Number 3, it's kind of a similar concept, except now it's not just giving you these different graphs. It's saying, look at all these points. Let's do some calculations here on your slope. Okay, so you know that slope. Okay, we always want to use that y2 minus y1 over x2 minus x1. All right, so we're going to do the same thing. We're going to do this for A. Let me give myself plenty of room here. B and C. Okay, I'm looking right here at number 3. Okay, so I'm going to say all of these right here, these are going to be all my 1 points. And right here, these are going to be all my 2 points, just to keep it consistent as I work through these. Okay, so as I'm doing line A, I want to plug in with this formula. So y of my 2 point is 2 minus y of my 1 point is negative 1 over x2 is 2 minus x1 is negative 4. Okay, so I get 2 plus 1 over 2 plus 4. I don't know why I almost wrote 5 there. All right, so I get 3 over 6, which simplifies to 1/2. So I know slope for A is 1/2. Let's move on and do B. All right, so point 2 right here is 5, 1. So, okay, y2 is 1 minus y1. Okay, y1 is negative 3 over x2 is 5 minus x1 is negative 5. All right, so that's the same thing as 1 plus 3 over 5 plus 5. Okay, that gets me 4 over 10, which simplifies to 2/5. And then over here, line C, same thing. So I'm thinking I've got y2 minus y1, so y2 is this negative 1 minus y1, that's that negative 3, over x2, which is 2, minus x1, which is negative 2. So I've got negative 1 plus 3 over 2 plus 2. So I'm going to end up here with 2 over 4, which simplifies to 1/2. All right, so I've got 3 different slopes here. I've got 1/2, I've got 2/5, and I've got 1/2. So I know that my lines that are parallel are these lines with the same slope. So what is that? Line A and line C. Okay, so my final answer here would be lines A and C are parallel. 1 R and 3 L's. I always almost misspell parallel. Lines A and C are parallel. Okay. Now we have another layer. I don't know if this is another layer of difficulty. I think this might even be easier than trying to find the slope. I think trying to find the slope over and over again kind of gets a little bit tedious. So let's look over here at number 5. If you need to still look at any of this slope stuff, go ahead and pause the video right now because I'm gonna erase it, give myself some room to work here for number 5. Okay. All right. So now it's asking me the same question. Which ones of these lines are parallel to each other? Except it doesn't give me points. It's giving me these different equations. So in order for me to figure this out, I've got to take each one of these. Okay, I've got to take A. Again, trying to give myself plenty of room to work. I'm going to do B. And over here, I'm going to do C. And on each one, I'm going to go through and I want to get it in slope-intercept form. Okay, good old slope-intercept form. Y equals mx plus b, so that I can see what m is. Okay, that way I can find what the slope is. That's how we're going to figure out if they're parallel. So we're going to have to do a little bit of algebra to figure out, okay, let's get this in slope-intercept form. Then we can look at the slope, figure out if they're parallel. So line A, I have 4x. Here, I'm going to move that A so it's not in the way. 4x is equal to negative 3y plus 9. Okay, my goal is to get just y on one side of my equation. So let's move this 9 over. Okay, 4x and negative 9 are not like terms. So I'm going to write this out as 4x minus 9 is equal to negative 3y. And I would rather have my y term on the left, so I'm not going to do any algebra here. I'm just going to switch which side these are on. So negative 3y is equal to 4x minus 9. Didn't change anything, just flip-flop the sides here. Then I need just y on its own. I'm multiplying y by negative 3 right now, so I need to divide here both sides by negative 3. Okay, so I'm going to be left with y. I need to divide both of these terms by negative 3. So this is going to be negative 4/3 x. And then negative 9 divided by negative 3 is positive 3. Okay, that's confusing. This is the same thing as if I wrote 4 negative 3. Okay, those fractions are the same thing. But when I write fractions, I like to have the negative on the top. It just helps me not make as many mistakes. All right, so first one, I get negative 4/3 here as my slope. Okay, so my m is negative 4/3. Now I need to go for b and c to find what slopes I get for those. So let's do, we've got 8y is equal to negative 6x plus 16. Right? This one is a little bit simpler because I've already got my y term already isolated here on one side of my equation. I just need to get rid of that 8. Okay, so I'm going to divide each side here by 8. Okay, so those 8s cancel out. I just have y. So I've got negative 6 eighths times x. Okay, 16 divided by 8 is 2. And then if I think about, let's simplify that fraction. I'm going to have negative 3/4 x plus 2. My m here is negative 3/4. Okay, that looks like it's trying to trick me because it's close to the other one, but not quite. All right, so let's look at C. Let's see if any of these actually are parallel. Sometimes you might have an answer where none of the lines are parallel. Okay, so I've got 4y is equal to negative 3x plus 9. Okay, so let's try and figure out what my slope is going to be here. All right, same as the other one. My y is already isolated on one side. I just need to get, I shouldn't say y is isolated, my y term is isolated. So I just need to get y by itself. I'm going to divide each side here by 4. If this stuff is confusing to you as I'm working it out, you could also write this where you're dividing every term by 4. It's the same thing either way. Both of those two ways that I just wrote it mean the same thing. Okay, so if it's easier for you to do each term rather than an entire side, you can do it that way as well. All right, okay, 4 divided by 4 here cancels out. I get y is equal to negative 3/4 x plus 9/4. I don't really care about the b values here. All I care about is my slope, and I get negative 3/4. Awesome. So it looks like my B and my C line both have the same slope, and my A not quite. All right, that one looks like it was there to maybe trip me up a little bit. So my answer for this one are going to be lines B and C are parallel. All right. I know each one of these problems seems like it takes so long. There's a lot of math to do for each one. I'll try and keep the homework fairly short. All right. Last one, let's do number 7. So it's not asking are certain lines parallel, it's asking to write an equation of the line that passes through the given point and is parallel to the given line. So it doesn't say what type of equation that it has to be. So let's think about it. It's giving us the slope. We have to think about it a little bit, but it's giving us the slope and it's giving us the point. So it's going to be easiest for us to do this in point slope form. Okay? Point slope form, remember it's that y minus y1 is equal to m times x minus x1. All right, so let's plug all the information that we have into that equation. If it had asked for it in slope-intercept, we'd have to do some more, but it's just saying the equation of the line, so we can leave that in point slope form. All right, so we have our point right here. There's our x1 and our y1. And then, okay, if it's parallel to this line, well, then it has the exact same slope as that line. So my m in this line, my m is 1/3 for this line, and it's going to be 1/3 for the line that I'm writing because it's parallel. They have the same slope. All right, so let's plug it into that point slope form right here. So I get y minus y1, which is negative 1. I'm not going to write out minus negative 1. I'm going to say plus 1. And that's equal to m, which I know is 1/3, times x minus x1, so minus 3. All right, and it didn't say what format it had to be in, so I'm just going to leave it in point slope form. Okay, I know that some of this is kind of a lot. It's a little bit tedious, but I think that I think that a lot of the math that we're doing is similar to what we've done before. We're finding over here, we're finding the slope. Okay, we're rearranging something to be in slope-intercept form. right? We're analyzing these slopes on these graphs, right? But if you need a little bit of extra help with this, remember on Monday through Thursday, I'm always available for office hours from 1:25 to 2, right? If you start hitting a wall with this stuff, that's perfectly fine. Just come find me during office hours. I'm in the same Google Meet, the A. Larson one, right? Make sure you're not letting yourself fall behind. Just make sure you ask any questions if you need it. And I will see you guys tomorrow.